Hello, good morning. Welcome to our first science class of the fourth partial. Now, we're going to be covering today the water planet. If I'm not mistaken, let me see here something. So, see, so currents and tides and ocean resources. Okay. So let's open our book. As we remember, the last of the third partial was the bodies of water, as we remember. You just have to make a map. And this section 1 covers the different bodies of water around the world, salt water or fresh water. It also shows us a diagram of what the ocean floor is. And these are things that you will have to know for this fourth partial. And as we know, we have the coast. And if I make the diagram over here too, so imagine that we have the ocean floor, and this is the beach. Okay, this is where palm trees are, coconut trees, and this is where people make their, their vacations. Now, in the beach, then we have, water coming in, and then we have the open seas. But today we're talking about the floor of the ocean. So this area that includes the beach, it's called the continental shelf. Okay, so this is the continental shelf. And as we can see, it is decreasing in altitude. It has a slant. So, and where it drops, then that's called the continental slope, because it's gonna have a big drop. This is the continental slope. Remember that this is the continent. Bodies of land, right? Continental slope. Continental slope. Slope in Spanish means pendiente. Okay, the continental slope. Then we have the abyssal plain, because in the bottom of the ocean, abyssal is abismo, and plain, planicie. So we have the abyssal plain, and then we have, for example, in the Atlantic Ocean, we have the mid-Atlantic ridge, which we remember from tectonic plates. Yeah, so, but that is in the Atlantic Ocean, and different oceans have their own ridges and trenches. So these are the basic parts of the ocean floor. The continental shelf, that is where the beach. On the continental shelf we also have coral reefs. Remember coral reefs? So this area is the one that has more diversity, because it's the area that gets a little bit more sunlight, but that we saw last year. Now, we have ways of calculating the ocean floor. What we use is sonar. We send a sound, then the sound bounces back, and because we know the speed of sound in water, we just have to calculate how much time it takes for one sound to come back. So if we send the sound, boop, and we wait for it to come back to the boat, then, because we already know the speed of sound, then we only have to calculate how much time it took for the sound to come back. And that is how we obtain a distance. Let me give you an example. Imagine that we have our boat over here. And we are going to send it a sonar. There's one thing we have to know. The speed of sound in water. The speed of sound in water is 3,600 meters per second, if I'm not confused. No, 1,500, sorry. It's like I just made up that number. Okay, so this is the speed of sound. Speed of sound. Okay, so what happens if we send a sound? We send a wave, and then the wave bounces by echo. It sends an echo, and it took the wave, the time that it took was 1.2 seconds. So we need to make a formula showing us that distance is equal to, and so speed is equal to distance over time. Then distance is going to be equal to speed times time. A little bit of algebra. So we are trying to find the distance. We don't know the distance, but we already know the speed and we already know the time. Now, well, we don't know the distance. This is our variable. The speed, we already know it. 1,500 meters per second. The time, we already know it. 1.2 seconds. And so we do a little bit of algebra, and this will get us to 1,800 meters. Okay, so this distance is the distance that it took our sound from here and back to here. So is this the distance of the ocean floor? No, because this is twice the distance, right? So if we want to know the distance to the ocean floor, we have to divide this number by 2. So we have to divide all of this by 2. 1,800 divided by 2 is going to be 900 meters. Okay? From here to here. So this is how we don't have to go to the bottom of the ocean to know what the ocean, because going to the bottom of the ocean is very difficult. Very difficult. Now, what other things do we have? Well, here's a very nice sonar photography made of the bottom of the ocean. We can see the trenches in the mid-Atlantic ridge. We can actually see the tectonic plates. If we look at the ocean floor, we are looking at the boundaries of the tectonic plates, people. We can see the trenches. Well, this is the mid-Atlantic ridge, which is the boundary between the American plate, South American, North American, and the African plate with the Eurasian plates. We can see all the boundaries. Check it out. And this is just by the ocean floor. Actually, the plate tectonics theory comes from, if you remember, from analyzing the ocean floor. Okay. Now, let me see if I have any people here. Yeah. Okay, remember to send me your questions via WhatsApp now. Okay, what else? Well, we have lakes and rivers. Now, why is the ocean salty? As we have seen before on the first and second partials, water has a cycle. You know, So let me make some territory here. Let me make a mountain. So as you can see, mountains are actually higher than what we think in terms of continent. So if we have the ocean over here, we need to remember that there is a water cycle. That water evaporates, then condenses. Winds may move the clouds, and the clouds may rain over the water. No problem there, raining over the water. But it becomes more interesting when it rains over the land. As we remember, water is the main agent of erosion and also the main agent of weathering. So with weathering and erosion made by water, what is happening? There's water is, with it in its downward gravity-driven path to the sea or to a lake. It also dissolves rock material. It also moves soil. So through weathering and erosion, we are having dissolved minerals moving from the land to the water. Now multiply this, this action, which is very slow, because rivers are not salty. They're not salty. Why? Because the amount of dissolved minerals they have is very small. Very small. So it's fresh water. But if you multiply the little bit of dissolved minerals that rivers bring to the ocean times the billions of years that this has been happening, then we have salt water oceans and seas. Okay, that is the reason why ocean water is salty. And throughout the different oceans, salinity varies, but we have an average of 3.5%. That means that out of 1 kilogram, 1 kilogram of ocean water, we have 335 grams of salt. And what is salt? Dissolved minerals. Okay, give me a second here. Hi, I'm back. Well, how does water affect temperature? We already saw that on the last chapter. Let's remember that water controls temperature, because if we have currents, for example, well, one thing is that water absorbs heat less fast than solids, but it also retains the heat more time. So places that are in contact with water usually have a milder climate. And also it depends on the currents. If you have warm water currents, then you still get all of this. The water interacts with the environment, the atmosphere around it. So if you have warm water currents, then your warm water, it transfers through convection the warmth. But if we have a cold water current on the other side, then it will transfer the coldness. So yes, bodies of water affect temperature. What else? Why does water exert pressure? Let's remember that every amount of matter itself exerts pressure. The weight of matter exerts pressure. And if air exerts pressure, imagine water, which is, is heavier than air, it exerts even more pressure. That is the main reason why it is so hard to go to the bottom of the ocean. Because every 10 meters, imagine that we are going underwater. Do I have another blue? Yes, I have another blue. Imagine going underwater and it's like going to a swimming pool. Remember what happens to our ears whenever we go down to the water? If you have done it, we receive pressure. Because every 10 meters, if you move 10 meters, every 10 meters that you descend in water, it is like the weight of 1 atmosphere. Okay? Every 10 meters is like having the weight of 1 atmosphere. So, every 10 meters, 1 more atmosphere of weight. Another 10 meters. So if we have 20 meters, then we have 2 atmospheres. Imagine having, this is 1 atmosphere. What we feel right now is 1 atmosphere. It's not too much, right? But every 10 meters we get more and more and more and more, until, imagine, in the lowest places of the ocean, you get 1,000 atmospheres. Even your submarine, can collapse, can crush itself with that much pressure. Okay. Then let's go. Remember, if you have any questions, submarines like this, submersibles, have to be really thick and very strong to sustain pressures. In fact, we have not gone to the, to the bottoms of the oceans because of this high pressure. It's not easy. If you have a vessel, imagine having a submarine. Let's make a better submarine over here. So we have the submarine over here, but if it goes really down, it will start to crush itself. No, it's not longer sustainable. So this is what water pressure can do. Okay, so if we go to chapter 15, lesson 1, we have waves. Waves. Okay, and what is a wave? It's what we call ondas, but we also call them olas. In the ocean, in Spanish, we call them olas. And that is why we always draw them like this. If you have been to the oceans or have seen videos about the seas and the oceans and the beaches, we will remember that the oceans are made of like this, and we can make waves whenever we are in water. Remember going to the pool? You can even make a wave in your glass of water. So waves are, an important property of ocean water. And let's begin by understanding what forms the waves. Okay, so a wave, what forms a wave in a glass of water? Motion. Motion forms waves. The motion of the water itself forms waves. So waves are motion. And what can cause a wave? Any motion itself can cause waves. For example, the motion of the Earth itself. Well, I don't think it affects so much, but what does? The motion of wind is one of the main causes of waves, but we also have movement of plate tectonics causes waves, even really big waves like tsunamis, earthquakes, for example, or volcanic activity can cause tsunamis. A landslide. Imagine that we have the continental slope over here, and we get a landslide. This causes waves. Even the motion of the animals inside it cause waves. If we have a whale, for example, you know. But the most important factor is wind, okay? And the movement of the wave itself, because waves have another characteristic, that they bounce. They bounce and they interfere with one another. So the motion of the waves themselves are, part of the okay, as such viewer. What is this? Okay, sorry, I'm looking at some internet things here. I hope you have a good signal and there's no problems here. Okay, so as I was saying, waves, waves. Surfers like waves. Other people don't like waves because they're dangerous. Yes, they have a lot of energy in them. They can exert a lot of force. If you have a storm, for example, then your boat. Okay. And one more thing we need to know: waves, from one crest to one crest, is called the wavelength. And that is the same from one trough to one trough. Wavelength, it's the same. And these two are the same. From crest to crest or from trough to trough, it is the same, the wavelength. Now, all of them you have in your book. And waves are going to be moving. So this is going to be moving to that, in one direction. So if we were to measure a wave period is the time between the passing of one crest and the passing of the next crest. So if we were to measure from this point, which is from one crest, so this crest is going to move to the next. So this passing from one crest to another crest is called a period. And the speed that it takes for one period to move is called frequency. But we're not going to discuss frequency right now. Well, actually, this is all just to know the parts of a wave. And, well, we have some diagrams over here showing us how waves also produce circular motion. But something interesting about the waves is that even though they are moving, the wave is like moving in one direction. If you have a boat, this boat will only be moving up and down. Even though the direction of the wave is in a certain direction, your boat is only going to be moving up and down. That is a particularity of waves that even though they have a direction of how they're going to move, the matter on the wave doesn't move. Interesting, right? So this boat is only going to be going up and down, and not moving in the same direction of a wave. So you cannot use waves so much to travel. You don't travel in the direction of the waves unless you know how to use the energy of waves. What does a surfer does? But because we have to talk about swells, and we have to talk about breakers. When the top of the swell moves too far, it forms a breaker. Now, breakers are the ones that we are accustomed to seeing surfers in. Now, what is a breaker? If we analyze the wave with the ocean floor in mind, we will see something. When the ocean floor, well, this wave is too big for this ocean floor. And let me make an ocean floor. Let me make the continental. I'm gonna make the continental slope over here and the continental shelf a little bit larger so that we can see what I'm talking about. So when we have a lot of water in between, we have these swells, okay, that don't break so much. They are not breaking. Why? Because remember, the circular motion has not been interfered. There's like a circular motion here below. So, but what happens when this circular motion is interfered with land? Then this circular motion is no longer permissible, so this brings the energy to back to the top, and that makes the wave become a breaker. And these breakers are the ones that surfers like to use, and these are the types of waves that we will be accustomed to seeing when we go to the beach. And these breakers don't happen on the open ocean. They only happen near the continental shelf, so near the beach. Why? Because the movement of water below the wave is interrupted by land. So that is the reason why breakers occur near the land. Okay. Tsunamis, as I told you, are big waves caused by earthquakes, volcanic activities, or landslides. Because, like I told you before, imagine that this continental shelf is getting eroded all the time by water, obviously. And what if it breaks? All of this mass of land is going to produce a lot of energy, and this energy is going to be transmitted, to the top, creating very big waves, very big swells when they break, and they may flood an area. So landslides are also a form of tsunamis. Also can form tsunamis, but as we know, earthquakes are, if we have an earthquake, that means the movement of tectonic plates, then you can also get an earthquake and a tsunami. Well, obviously a tsunami. Okay, do we have time for currents and tides? Yes. So currents. Currents are caused. What is a current? It's the flow of water. Even the oceans itself have currents. If you go to page 461, you will see some of the world's main oceanic currents. What does this mean? That inside the ocean we have currents that form. And why do they form? The same thing as planetary winds. Remember planetary winds? They are formed because of differences in temperature, which create differences in pressure. And check it out. So if you're looking at page 461, you will see that along the equator we have warm water currents, and they are moving in this direction. Why? Because of the Coriolis force. Remember, the Coriolis force is the force of the Earth rotation. So they are moving in this direction because of the Coriolis force along the equator. But because we have differences in temperatures of the water along the poles, then we get different currents in, and the differences of pressure that they create also create circles and cycles, as we can see. So along the equator we have warm water currents, and in the polar regions we have cold water currents in the opposite direction. So they create a loop. So, and these water currents are water moving. It's actually water in motion with a temperature. They bring temperatures, and they, animals. Remember the movie Nemo? The turtle they were going through a current. So those are surface currents. Surface is superficie, okay? So we have currents at the surface, that can be moving in one direction, but we can also have currents underneath. But the ones we are talking about are surface, superficie. Now, surface currents, they can be used for traveling by boat. So if you're on a current, on a surface current, you can be traveling in this boat with the current. No problem there. Okay. Remember, if you have any question, tell me about it. Now, we have another current that is called the shoreline currents on the next page of our book. And these are the currents created on the beach, because when the wave gets to the beach, it will bounce. So we have this is called a shoreline current. And these are the ones that parents are the most worried about. Los padres de uno le dicen, cuidado te lleva la corriente. And these are the currents that we are talking about, the shoreline currents, because the waves are coming to the beach, but they are going to bounce back to the ocean. And those are the shoreline currents. They go back because the bouncing of the waves. And when you go to the beach, you will see that, you're going to be moving a lot on the beach. The currents that happen on the beach, if you think you're standing still in one place, no, you're never gonna stand still in one place. Okay, and finally we have tides and tidal currents. And these are caused mainly because of the moon. Now, imagine we have planet Earth over here, and we also have the moon over here. The moon exerts gravity just as much as the Earth exerts gravity on the moon, because gravity is a two-way thing, Now, but the gravity of the moon, we cannot feel it, but water can feel it. Because water is not as heavy as solid objects. What happens when the moon is in one direction? The water of the oceans is going to be a little bit attractive. I'm exaggerating here, right? But actually, as you have seen, and this is what we call tides, mareas. right? Look at the photographs here, right? This is the effect of tides, of the mareas. So that means that at one point of the day, you will have a high tide and you will have water on your beach. But at another part of the day, you will have a low tide, and that means that you won't have water on your beach. And what causes these tides? The moon. The moon is the one that causes the tides, because when the moon is moving, the tides, the water levels follow in two directions, in the direction to the moon and in the opposite direction. If the moon is over here, then our tides change with the moon. When the moon is over here, then the tide is going to change with the moon. So we can see that around the world, tides are changing. They are following the moon. Well, this moon should be over here. And as we can see on the next page, and if we add the sun to the equation, the sun also has an effect of gravity, and if we have the earth over here and the moon over here, then the tide is going to be even higher. Super exaggerated, obviously, but I want to exaggerate and stress the point that tides are caused by the gravity, especially of the moon, but they can also be helped by the gravity of the sun. So this is what we call tides and tidal currents, because the water is moving when creating the tides. Then this is what we call tidal currents, because what happens, let's look at tides when we are on the beach. If you have a high tide, then your water level is like this, very high. But if you have a low tide, then the water level comes down. And how does it come down from here to here? Well, it's going to be creating a current, a tidal current. So no longer will we have the high tide, we'll have a low tide. And when the tide is preparing to go back up, well, this is going to create a current also. And now we have a high tide. And if you are a fisherman, or if you are a sailor, a person of the seas, it is important for you to understand how tides behave. You have to, people that live on the beaches and that are in close contact with the oceans, like fishermen or sailors, they, this is part of their, everyday knowledge. Tides. What are you gonna do with tides? Because sometimes there's going to be land, but other times there's going to be water. Some people even know how to fish, because imagine that you have a high tide and you put a net over here. When the tide is low, check this trick out. When the tide is low, all the fish are going to be trapped on the net. So you will fish. Let me put some fish over here, some green fish. So all your fish are going to, that's a way of fishing, for example. And let's remember that some places are using hydroelectrical energy, using also the energy of the tides, the energy of the waves, and the energy of currents. Well, people, this is it. If you have any questions, please send them to WhatsApp, to the group, and I will try to answer them as I can. So, see you next time. Bye-bye. And remember that we have a quiz Monday, I think. Yes.